So let me introduce our first pre-recorded speaker. Nicole Nelson-Jean is serving as the Associate Principal Deputy Assistant Secretary for Field Operations for the Office of Environmental Management, EM. Nelson-Jean has overriding responsibility to support the 16 EM field sites working throughout the nation to clean up and safely deposit large volumes of nuclear waste, safeguard and prepare for disposition of nuclear materials, deactivate and decommission several thousand radiologically and chemically contaminated facilities, and remediate extensive surface and groundwater contamination. I forgot to say this is Z13, and the overall topic is radioactive nuclear waste, a problem not going away. The title of Ms. Nelson-Jean's talk is Status of Environmental Cleanup Conducted by the Office of Environmental Management, U.S. Department of Energy. So I'd like to start the pre-recorded talk now.
Hello, everyone. My name is Nicole Nelson-Jean, and I am the Associate Principal Deputy Assistant Secretary for Field Operations within the Department of Energy's Office of Environmental Management. My office develops strategies, policy, and guidance for field operations to support the Office of Environmental Management's mission. In addition, I oversee nuclear operations, safeguards and security, and technology development. Our mission is to complete the safe cleanup of the environmental legacy brought about from decades of nuclear weapons development and government-sponsored nuclear energy research. Our first priority is to ensure the safety and health of the public and workforce while continuing to protect the environment. Here is our latest organizational chart. Mr. Ike White currently serves as our Senior Advisor for the Office of Environmental Management. Since the inception of the Office of Environmental Management in 1989, we have completed cleanup of 91 of the 107 sites. As you can see on the map, we have reduced the footprint by 90% to less than 300 square miles. Despite the COVID-19 pandemic, we have made tremendous strides in our environmental cleanup work. We work collaboratively and leverage new approaches to advance our mission. This is true testament to work ethic and dedication of the federal and contractor employees. I now would like to talk to you about the Office of Environmental Management strategic vision for 2022 to 2032. This document shows where we want to be in the future and helps us stay focused on our environmental cleanup mission. This is the third iteration of the strategic vision, and it will be updated annually to better reflect program progress, budget profiles, and anticipated accomplishments. Regarding safety and security, we will continue to perform our activities with a strong safety culture that integrates environmental, safety, security, health, and quality controls in all work activities. For program and project management, we have performed several root cause analysis to better understand why some projects have experienced cost and schedule issues. Lessons learned from these analyses resulted in implementation of a set of actions across the cleanup complex. These include new project management capabilities and requirements, improved reporting, and increased guidance and training. When it comes to acquisition, the contract is one of our most important tools to execute our mission. It defines the requirements and expectations of performance between the government and our contractors. We will continue to be demanding client. We expect the contractors to perform in a safe, efficient, cost-effective manner with the highest ethical standards. We will continue to develop and improve acquisition tools, processes, and resources to increase efficiency in competing and awarding contracts. For regulatory and stakeholder engagement, we actively work with our regulatory partners in negotiating compliance agreement priorities and milestones for individual sites. We are focused on identifying methods for streamlining regulatory approaches and accelerating cleanup. We are pursuing strategies that are more cost-effective, technically sound, and protective of workers, the public, and the environment. Regarding infrastructure, we face the continued challenge of performing environmental cleanup activities at sites with decades-old infrastructure. In some instances, the infrastructure originated in the World War II era. We are achieving success in infrastructure upgrades that will amplify the ability to perform environmental cleanup in the future. On the topic of next-generation workforce, we are committed to promoting and supporting an inclusive environment, one that provides all employees the chance to work to their full potential. We continue to use diversity and inclusion training and education tools to enhance our working environment. We are also expanding our recruitment strategies and leadership development programs to foster the workforce for the future. Regarding innovative approaches, it is critical to develop these approaches to perform our environmental cleanup activities and complete our mission. Such approaches should be science-based and focus on managing and disposing of waste in a safe manner, consistent with statutory and other legal requirements. One such approach is the department's interpretation of the statutory definition of high-level waste. This interpretation enables some reprocessing waste to be disposed in accordance with its radiological characteristics and not solely where it came from. We have applied this interpretation for an initial waste stream at the Savannah River site in South Carolina. We are in the process of completing the analysis for the second waste stream, also at Savannah River site. Additionally, we are also seeking to enhance our technology research and development efforts. This will enable us to better identify and demonstrate new and innovative approaches for tackling cleanup challenges. Regarding potential opportunities for acceleration, we continually work to identify and assess opportunities to accelerate cleanup project towards completion. We conduct regular analysis of alternatives that support innovation and reduce cleanup schedules. On the topic of radioactive waste disposal, it is a core function of our program. Without radioactive waste disposal capabilities, environmental cleanup cannot proceed. We keep waste disposal decision-making transparent. Input from the public, tribal nations, and stakeholders is received within the framework of the National Environmental Policy Act, documentation, and appropriate regulatory process. I would now like to give you some recent environmental cleanup site updates. The tank side cesium removal system at the Hanford site in Washington has been completed. The system removes radioactive cesium and undissolved solids from waste currently stored in large underground tanks. The tank-size cesium removal system began treating tank waste in January 2022. The waste treated through the tank-side cesium removal system will be stored in a double-shell tank until it is fed directly to the waste treatment and immobilization plant's low-activity waste facility. approximately 930 kilogallons of waste will be treated and transferred into the tank AP-106 by the end of the calendar year. On December 6, 2021, the last of the targeted buried waste was exhumed from the Idaho Subsurface Disposal Area. The exhumation effort began in 2005 and was completed about 18 months ahead of schedule. Crews removed more than 10,300 cubic meters, or about 49,500 drums. The before photograph on the left shows uncovered waste drums in one of the first disposal pits excavated. The buried waste was removed from disposal pits covering 5.69 acres at depths of up to 30 feet under the surface. The middle photograph shows an extended arm excavator removing the final amounts of targeted buried waste from the last disposal pit. The picture on the upper right shows the entire subsurface disposal area. The white enclosure facilities were constructed over the disposal pits to ensure protection during the exhumation, processing, and repackaging operations. The photograph on the lower right shows the waste processing and repackaging operations after exhumation. At the Nevada National Security Site, regulatory approval and data completeness for the Paducah Mesa groundwater region was obtained. This is the last active groundwater corrective action area at the site. This is a key step necessary to advance environmental corrective action strategies at the Paducah Mesa groundwater area. With initial data collection and analysis complete, EM Nevada experts have begun developing sophisticated scientific models to forecast where and how contamination might move within the groundwater under Paducah Mesa. The Paducah Site in Kentucky houses one of the largest inventories of R114 refrigerant, commonly known as Freon. In 2020, the Paducah Site began a campaign to remove approximately 8 million pounds of R114 refrigerant. The R114 refrigerant was used in the gaseous diffusion process. Through 2021, approximately 1.7 million pounds of the R114 refrigerant were removed and sent to an off-site facility for processing. In 2022, an additional 1 million pounds is anticipated to be removed from the Paducah Site. We hope to complete the campaign removing 1 million pounds per year through 2026. As you can see in the photograph on the right, demolition continues at the X326 building at the Portsmouth site in Ohio. In January 2022, the site reached a 50% complete interim milestone and expects to have the building to ground in 2022. The building is massive, nearly a half-mile long. It required significant deactivation to remove hazards before being declared safe for demolition in late 2020. This building is the first of 3 former Portsmouth gaseous diffusion process buildings to be demolished. The X326 building is the most contaminated of the 3 process buildings. Lessons learned and techniques developed at X326 are helping facilitate deactivation of the site's other 2 large gaseous diffusion buildings, X333 and X330. Additional saltstone disposal units at Savannah River Site in South Carolina are being constructed to store large volumes of decontaminated salt solution safely and permanently. The salt solution was generated at the salt waste processing facility. Completed saltstone disposal units 6 and 7 can hold up to 33 million gallons of saltstone. You can see the saltstone disposal units as labeled on the slide. Saltstone Disposal Unit 7 became operational in July 2021. It was under cost and ahead of schedule. Construction continues simultaneously on the Saltstone Disposal Units 8 and 9. Significant progress has been made on both. I now would like to give you an overview of our involvement in the Justice 40 initiative. The Justice 40 initiative is a requirement of Executive Order 14008, tackling the climate crisis at home and abroad. The Justice 40 initiative is a government effort to deliver at least 40% of the overall benefits from certain federal investments to disadvantaged communities. We are proud that the EM Los Alamos site in New Mexico was chosen as a Justice 40 Initiative pilot program. We will continue to work with the administration on the next steps of the Justice 40 Initiative and its application at our cleanup sites. This is a unique opportunity for the Office of Environmental Management to show its ongoing efforts to support disadvantaged communities. This now concludes my presentation. Thank you to the American Physical Society for having me present. I hope you enjoy the conference.
Okay. As I explained at the beginning, Ms. Nelson-Jean was a recorded person. She's not even sitting in her office, but nevertheless, I would like to take questions for her, which I will forward to her by email. And so if there's anybody in the room who would like to ask a question, or if you happen to be a stakeholder, she mentions stakeholders, which are the communities around these contaminated sites, then I welcome you to come up and ask a question. I'm going to check if there's any virtual attendee who wants to ask a question. I would also like to point out that our next speaker is actually working on the Hanford site that was mentioned in Ms. Nelson-Jean's recorded video. And so you will hear more about the efforts to clean up that very large site, which is where most of the nuclear weapons, well, most of the plutonium that was needed in the nuclear weapons that were dropped on Hiroshima and Nagasaki in 1945. That was where the plutonium was produced. And you will learn from our second speaker how much waste was left behind and the tremendous effort it is to get rid of it, which is why we're having this session. The three speakers following our two Department of Energy related people are actually community members who are suffering from some of these not so good efforts. You heard a very glowing description from Ms. Nelson-Jean about the efforts that the Department of Energy is taking, but you will hear from our last three speakers that they're not altogether happy with those efforts. And we still have 13 minutes to go. We are always asked to keep to schedule, and so I'm not going to start the next speaker until we hit that time. So, as I said, yes, please speak your question into there. Thank you.
Well, I have a somewhat naive question, which is presumably the original storage facilities for all of the nuclear waste that the DOE has been working on removing were intended to be permanent. And so we've heard that the new storage facilities are also intended to be permanent, and I guess I'm wondering what the feasibility of that is, if we think we really got it right this time, and what evidence we have that these facilities will in fact be more permanent, or if we're going to learn something. How likely is it that we're going to learn something in another 20 years that's like, oh, this was in fact not a good permanent solution. We'll need to go through another expensive effort to redo it all over again?
That's an excellent question, which I am not qualified to answer, but I do believe that especially our second speaker, who's working at Hanford and dealing with these underground tanks. There wasn't a picture of the Hanford, but he may show you these underground tanks. I'm hoping, Tom, that you will be able to answer that question about how likely is it that this new storage places are going to work for a long time. I saw another question coming up on the Slido, so let me repeat that for everybody. The other thing to note is, because we're being live streamed, this whole session is being recorded. And after a day or two, those recordings will appear on the Freeman website, and you can, if you're a paid attendee, you'll be able to watch them again. Just a minute, let me see about the question on the Slido. Hang on. Yeah, so an anonymous person says, what is the estimated budget for this waste management? And again, I don't have the answer. Maybe one of our next speakers has an idea of what the Environmental Management Department's estimated budget is. So my other speakers, please keep that question in mind. Okay, so now we have another question from the audience. Thank you. Speak up.
Well, nuclear waste is being encapsulated in steel tanks. Corrosion of metals is a problem. Those alloys were designed to last from 50 to 100 years, but essentially corrosion eats those metals, and radioactive waste escapes. Nuclear waste is not the only source of radiation. As you probably know, Nevada is more nuked place than Japan. Only 2 nuclear bombs were exploded in Japan. More than 900 nukes were exploded in Nevada. Some of those nuclear explosions were on the surface, and that resulted in radioactive pollution, which is still there. So here is a question. In the United States, we have places like Nevada with radioactive pollution. Sometimes it happens in unexpected places. In the United States, we have the police. Would it be nice to equip police vehicles with Geiger counters so that police officers can detect radioactive places and report them? Thank you.
Thank you very much for that question. Ultimately, you asked if police, just regular police, I suppose you meant, could be equipped with Geiger counters so that they knew when they were responding to some incident, I presume, whether there was some radioactive contamination they should know about, right? Okay, I'm trying to write these questions down as they happen. And any other questions? We still have 8 minutes before the next person. Let me see if there are any more questions from the virtual people. Not yet. Do any of you live near in New Mexico, for example, or Nevada. Our previous questioner was, of course, referring to the fact that nuclear bombs were tested in the Nevada test site in the atmosphere for many years. And, of course, that wasn't the only test site. The Marshall Islands, way over in the Pacific, suffered several hundred tests in the atmosphere, and that has ruined their islands, as you can read about. If you were to Google Marshall Islands and radioactive waste, you would find out about that. We are talking today about radioactive waste here in the US. Unfortunately, the world, the nuclear weapons countries tested their nuclear weapons in various places, like in Australia, in Kazakhstan, in the Marshall Islands, in other islands in the Pacific, and the world is still suffering from the fallout of all those bombs. You've probably heard of Bikini Island. That was, and the bombs that were tested were actually much stronger than the bombs that were dropped on Hiroshima and Nagasaki. And there was eventually a comprehensive test ban treaty where the nuclear weapons, the countries owning nuclear weapons, agreed that they would only test underground and not up in the sky. And that was a help. That was because it became apparent that the radioactive fallout that was falling to the ground, to the grass, was eaten by the cows. And this fallout, of course, spread completely across the US from Nevada because of the winds. And so the milk, the cow's milk, had radioactive components, and that was then drunk by school children in the US. And so the school children were getting to drink radioactive milk. All of this is very well described on various websites that you can find by doing a search on the internet. That was the reasoning for stopping exploding nuclear weapons in the air. Okay, so we've now 5 minutes to go. So let me see if there's any other questions. Please, virtual attendees, do ask your questions. I will be forwarding them to Ms. Nicole Jean. And my other speakers, if you can answer any of these questions that have come up, I'd appreciate that. Yes. Okay, so here is another anonymous virtual speaker, a virtual attendee, who's asked, it would be nice to have some more detail about the innovative technological methods that are now being implemented for environmental cleanup. What are they, broadly speaking? The previous talk was not so useful for physicists looking to understand the technological challenges of this issue. Okay, I do believe that some of our speakers coming up will be able to, will be talking about innovative technical methods. And so please keep listening to our remaining speakers, and you will, maybe some of these questions will be answered by them, as our Department of Energy representative wasn't able to be here in person. So I'm just going to be jotting down these questions so I can send them to our speaker.